3.4 on exponential and logarithmic equations. So there aren't any actually notes to take here. We're just going to be solving equations using the properties of exponential and logarithmic equations that we've learned in this chapter. So example 1, I have 4 to the x plus 2 power equals 16 to the x minus 3 power. So in this case, a lot of times it's helpful to get the bases to be the same on both sides of the equation. So I'm going to leave 4 to the x plus 2 power because I know that 16 is the same thing as 4 squared. Now because I changed 16 to 4 squared, the 2 exponent is still going to be multiplied times the x minus 3 that's already there. Once I do that, if the bases are the same, then I can drop the base on both sides, and x plus 2 will equal 2x minus 6. Then I can just solve the equation from here. So I would subtract x on both sides and add 6 to the other side. So then I would have 8 equals x. We always want to go back and check our work to make sure this is an actual solution to the equation. So if I go back and plug in 8, I want to see is 4 to the 8 plus 2 power the same as 16 to the 8 minus 3 power? Well, this will be 4 to the 10th, and I'm trying to compare that to 16 to the 5th. And when I type those in the calculator, they are the same value, so x does equal 8. Okay, same thing on number 2. I have 1/3 raised to the n power equals 1 over 81 to the 2/3 power. So I want the same base on the left and right hand side of the equation. So I'm going to change so that they both have a base of 3. So I know 3 to the negative 1 power is the same as 1/3. So this is still negative 1 times n equals, I'm going to change 1 over 81 to 3 to the negative 4 power times the 2/3 that was already there. So since the bases are the same on the left and right, I can drop the base, and negative n equals negative 8 over 3. So then positive n equals 8 over 3. So now I can plug back into the original equation and see if this is a true statement. So I want to know if 1/3 raised to the 8/3 is the same as 1 over 81 raised to the 2/3. And it turns out that both of these do equal about 0.5342. So n equals 8 over 3 is the correct answer. Okay, number 3, I have 7 minus 3 log of 10x equals 13. Our goal is to get log 10x by itself first off, and then we'll solve for x. Okay, so to get log 10x by itself, first thing we're going to subtract 7 on both sides. So then I'll have negative 3 times log 10x equals 6. I'm going to divide by negative 3. So log of 10x equals negative 2. Now that I have log equals a number, I can rewrite this in exponential notation. And I know that logs are base 10 unless otherwise noted. So I'm going to rewrite this in exponential. So this will be 10 to the negative 2 power equals 10x. Then I can divide by 10 on both sides. And I went ahead and wrote that 10 to the negative 2 is 0.01 equals 10x. And then I divided by 10. So x equals 0.001. So we always want to check our work. So I want to plug in 7 minus 3 log of 10 times 0.001 and see if that's equal to 13. And it is equal to 13. Okay, so number 4 says log base 5 of x to the 4th equals 20. So again, if you have log equals a number, then rewrite in exponential. So this is 5 to the 20th power equals x to the 4th. So then to get rid of the 4th power, I want to raise to the 1/4 power on both sides. So then 5 to the 20th raised to the 1/4 is actually 5 to the 5th power equals x. So then x equals 3,125. So So again, we want to plug in to check. So log base 5 of 3125 raised to the 4th power, and that does equal 20. Okay, example 5, log base 2 of 5 equals log base 2 of 10 minus log base 2 of x minus 4. So what I want to do first is on the right-hand side, I want to condense that to a single logarithm. So log base 2 of 5 equals, since I have two logarithms that are being subtracted and they have the same base, that changes to division. So log base 2 of 10 over x minus 4. So now that I have a log equals a log and they have the same base, I can drop the logs and set 5 equal to 10 over x minus 4. So we want to get x by itself, so I'm going to multiply by x minus 4 on both sides. So on the left-hand side, that's going to be 5x minus 20 equals 10. Then we'll just solve for x. So we're going to add 20 to both sides. 5x will equal 30, so then x equals 6. So always plug back in. Log base 2 of 5 equals log base 2 of 10 minus log base 2 of 6 minus 4, which is 2. So these are equal, so x equals 6 is correct. Okay, number 6, log base 5 of x squared plus x equals log base 5 of 20. So since I already have a log equals a log, I'm going to drop the logs and solve. X squared plus x equals 20. Since this is a quadratic function, I'm going to move the 20 to the left-hand side, and we need to factor. So two terms that multiply to get x squared are x and x. Two terms that multiply to get negative 20 but add to get positive 1 is going to be plus 5, negative 4. So then I set each factor equal to x, and x is going to equal negative 5 and 4. So we're going to check both of these. So when I plug in negative 5, and be very careful about when you plug in a negative and you're raising it to a power, that's going to make that a positive 25 plus a negative 5 would be log base 5 of 20. So those are equal. Same thing for the 4. 4 squared plus 4 will also be 20. Okay, number 7, 3 to the x power equals 7. So it's in exponential. You can write this in logarithmic if you want to. So this will be log base 3 of 7 to the x power, or equals x, sorry. So then I can use the change of base formula, and I could type log 7 divided by log 3. And this is approximately 1.7712. So then when I plug back in, I'm going to use that whole number and not just what I've rounded, raise 3 to that power, and it does equal 7. Okay, number 8, e to the 2x plus 1 equals 8. Since this is base e, I'm not going to write it with log. I'm going to write the natural log, base e of 8 equals 2x plus 1. So base e is understood, so I can just write natural log of 8 equals 2x plus 1. I want to subtract 1 on both sides, so I'm going to keep this as natural log of 8 minus 1 equals 2x, and then divide by 2. And I'm going to wait and type this all in at one time so that I only have to round once. So the natural log of 8 minus 1 and then divided by 2 is approximately 0.5397. So then when I type e raised to the 2 times that answer plus 1, it does equal 8. Okay, number 9, I have 4 to the x plus 2 power equals 3 to the 2 minus x power. So in this case, when I have a variable in the exponent, then I want to take the log of both sides so that I can bring those exponents down. So log of 4 raised to the x plus 2 equals log of 3 to the 2 minus x power. I can bring the exponents in front of the log. So x plus 2 times log 4 equals 2 minus x times log 3. I'm going to distribute, so this would be x log 4 plus 2 log 4 equals 2 log 3 minus x log 3. Anything that has an x with it, we need to move to the left-hand side. Anything without x's goes on the right-hand side. So this would be x log 4 plus x log 3 equals 2 log 3 minus 2 log 4. On the left-hand side, I'm going to factor the x out front, and I'm actually going to combine those two logs. Since it would be addition, it changes to multiplication. 4 times 3 will equal 12. On the other side, I'm just going to leave it 2 log 3 minus 2 log 4. Okay, so the next slide, I'm starting at the same point. I need x by itself, so I'm going to divide by log 12. So in my calculator, I'm going to type 2 log 3 minus 2 log 4, all divided by log 12, and that's approximately negative 0.2315. Okay, last example. I have e to the 2x power minus e to the x minus 2 equals 0. So I can't rewrite this into logarithmic yet. This problem will actually factor similar to the way that a quadratic function factors, because e to the x times e to the x will be e to the 2x power. So you can just pretend like this is a quadratic function. And then two numbers that multiply to get negative 2 but add to get negative 1 will be negative 2 and positive 1. So then I set each factor equal to 0 and solve. So this would be e to the x equals negative 1, which is the same as the natural log of negative 1 equals x. And if I type this in my calculator, this is a non-real answer because I can't have or find the natural log or the log of a negative number. Okay, on the other side, e to the x will equal 2. So then the natural log of 2 equals x. And if I type in the natural log of 2, this is about 0.6931.